Hello everyone, my name is Jahnavi and now we are here to present Huffman coding. Huffman coding is a lossless data compression technique. It compresses the file without any loss of data. It is invented by David A. Huffman in 1952 as a part of his MIT research. It uses variable length binary coding. Higher frequency characters uses shorter code and lower frequency character uses longer code, which is when sometimes you write a paragraph, it contains characters. There will be characters, most frequent characters and low frequent characters. The most frequent characters will get shorter codes and the less frequent characters will get longer codes so that the file length will be compressed but the data will not be lost. It ensures that data occupies minimum bit length, widely used in multimedia formats like compression. Why fixed length encoding is inefficient? Fixed length encoding is inefficient because ASCII assigns the same 8 bits to every character. Even the character do not appear with the same frequency in the real text. In English, letters like E, T, A, O and even space occurs very frequently. So using 8 bits for them every time uses a lot of storage. If characters that appears often are given shorter codes and rare characters are given longer codes, the overall file size can be gradually reduced. This idea is basis of the variable length encoding and Huffman coding applies it by assigning short codes to frequent characters and long codes to infrequent characters. As a result, Huffman coding uses space much more efficiently than fixed length encoding.
I'm Harshavardhan and my rule number is AP2411001161. Now I will talk about why Huffman coding is needed and then I'll explain its main properties. Need for Huffman coding. Huffman coding is one of the most widely used methods for lossless data compression. The main reason we use it is because it helps reduce storage space by assigning shorter codes to frequently occurring characters and larger codes to less frequent ones. It reduces the overall size of the data. This reduction in size also helps increase file transfer speed. When the file is smaller, it naturally takes less time to upload, download, or transmit over a network. Another important advantage is optimizing bandwidth usage. Since compressed data uses fewer bits, it makes communication systems much more efficient, especially in areas where bandwidth is limited. Huffman coding also has a low memory footprint, making it ideal for resource limited devices such as embedded systems, IoT devices, and mobile systems. And one of the biggest strength is that it can encode large data sets efficiently without losing information because Huffman coding is strictly lossless. Properties of Huffman coding. First, it is lossless. This means no data is lost during encoding or decoding. The original data can be perfectly reconstructed. Next, it uses prefix free codes. This means no encoded bit sequence is the prefix of another. Because of this property, the decoder never gets confused and the data can be decoded uniquely and correctly. Huffman coding is also optimal for a known set of symbol frequencies. It produces a minimum total length of embedded data compared to any other prefix-free code. It follows a greedy algorithm, meaning at each step it makes the best immediate choice, specifically combining the two least frequent symbols first. This greedy strategy is what ensures the final code is optimal. And finally, Huffman coding uses binary tree structure. The codes are generated through tree traversal, where going left or right adds bits to form the code words. So overall, Huffman coding is extremely important because it provides efficient, lossless comparison and is backed by strong properties such as optimality, prefix-free codes, greedy construction, and a clear binary tree representation. Thank you.
Hi, my name is Shetan and my roll number is AP2411001103. Now we are going to discuss about how Huffman algorithm works. Okay, let's Huffman algorithm, which is the most efficient works, which is used in most data compression. You may not realize, but Huffman coding is used in many everyday technologies such as zip conversion, JPEG, MP3 audio, and even text messaging systems because it reduces file size without losing any information. Okay, let's talk about step by step. Now let's discuss about the step one. Count the frequency of every character. We start with the text or data that we want to compress. The first thing we do is count how many times each character appears in the text. And each character appear more often or more important in compression because reducing their representation saves more time. Now let's discuss about the second point, second step. Create a mini priority queue of nodes based on frequency. Next, we talk each about doctor about the frequency and insert them into a min heap, which is a priority queue, where the element with the lowest frequency always come out first. This structure helps us efficiently find the least frequent characters, which is essential for building the Huffman tree. Now let's discuss about the step 3. Remove the two frequent nodes and the nodes mentioned, the step 3 and step 4. We take two nodes with the smallest frequencies, remove them from the heap and merge them into a new node. This new node represents the combined frequency of the two characters. The idea is that the least frequent characters should end up deeper in the tree because that gives them longer binary codes in comparison the acceptable and they appear rarely. Now step 5. Insert the new node back into the heap. We insert in this newly created combined node back into the priority queue. At this point, the heap again organizes itself to the next smallest frequencies rise to the top. This combining process continuing to build a binary tree from the bottom up. Now about talk about step 6. Repeat until only the root node remains. We keep repeating the same steps, taking out two nodes, merging them and rinsing until then there is only one node left in the queue. This final node becomes the root of the Huffman tree, which is a complete binary tree representing the structure of our compressed data. Let's talk about the step 7. Traverse tree into their assigned codes. Once the tree is constructed, we assign binary codes to each other. This is done by simply traversing the tree. Going to the left side adds 0 and going to the right adds 1. Each character ends up with a unique binary code depending upon its own path. Frequent characters are closer to the root so they get shorter codes. Less frequent characters are deeper so they get longer codes. This is what makes Huffman coding is so efficient. Let's talk about the step 8. Extract codes for each other. Finally, we read off the binary codes and each character. These codes are then used to encode the original text, significantly reducing the amount of memory needed. Now, the conclusion of the algorithm. Huffman algorithm is a smart and elegant algorithm that compresses data and by assigning shorter codes to frequent characters and longer codes to the frequent ones. This results in optimal prefix compression that saves store space and speeds up the data transmission. That's it.
Hello, my name is Arun Kumar and my roll number is AP2411001172. Now let's look at the example of Huffman coding. The slide shows Huffman tree that is constructed from the message spam 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 egg plus spam. The idea behind Huffman coding is simple. Characters that occur more frequently should get shorter binary codes, and characters that appear less frequently get longer codes. This helps reduce the total size of encoded message. As we move on through the tree, every left branch represents 0 and every right branch represents 1. Because of this structure, each character ends up with unique bit pattern and no code becomes a prefix of another code. This property is called prefix coding and ensures that decoding is never ambiguous. For example, characters like S and P, which occurs often in the message, are placed close to the root of the tree. This means their binary codes are much shorter compared to less frequent characters like E or G. At the bottom of this slide, you can also see the table, the frequency of each character and its assigned Huffman code. This entire process results in more efficient representation of the message, reducing overall size while ensuring accurate decoding. Now, now let's talk about the efficiency of the Huffman coding algorithm. Huffman algorithm is mainly focused on building a binary tree using minimum heap, and most of its time complexity comes from the heap operations. Creating the min-heap from the list of characters takes O of n time. After that, the algorithm repeatedly extracts the two smallest nodes and merge them. These operations involve heapify steps and together take O of n log n time. Once the tree is constructed, we perform a tree traversal to assign binary codes, which again takes O of n time since each node is visited exactly one. So overall total time complexity is typically expressed as O of n log n. In terms of space complexity, we need space to store all the nodes of the tree, which is O of n. We also store the final code table that maps each character, so it's binary code, which again requires O of n space. So the algorithm both time efficient and space efficient, making it powerful method for lossless data compression.
Hi, my name is Hindu Kumar and my registration number is AP2411000105. I will explain the Huffman code. Huffman code is a lossless data compression algorithm. Its main idea is to assign shorter binary codes to more frequent characters and longer binary codes to high frequent characters. This helps to reduce the overall size of the data. Now, let's dive into the code. At first, we have structure. The structure is a node created using a the structure contains some character C, int frequency, and two pointers. One is left child pointer, and another one is right child pointer. Now there is another function called comparator function. This function compare is used to in a priority queue in heap. It ensures that the code with the least frequency is always given the highest priority. This is important because Hoffman's coding always merge into the smallest frequencies. Now there is another function generating Huffman codes. That is generate codes. The function generate codes is a recursive function. If the root is a leaf node, it prints the character and its binary code. When we move left, we add 0 to the code. If we move right, we add 1 to the code. This way, every character gets a unique binary representation. Let's discuss about the main function. In main function, we have given the input spam egg plus spam. Here there are characters you can see as P, A, M. The space is also taken as the character, and GE, the operator plus, is also taken as character. And these are the frequencies of the characters that are stored in the vector. Um, Now let's discuss about the priority queue. Each character is put into the priority queue based on its frequency. The two least frequency nodes are removed and merged into a new node. This merging continues until uh, one of one of the node remains. The final node forms the Huffman tree. After the tree is built, we generate codes function is called to create the final codes. Once we have the codes, the input text is encoded by replacing each character with a corresponding Huffman code. This encoded message is much shorter than the original text in binary form. In short, we can say that this code builds a Huffman tree, generates optimal binary codes, and compresses the given text efficiently. That's how Huffman coding helps in data compression in real-world applications such as GIF files, images, and multimedia formats.
My name is Yashwant. My register number is AP2411001159. Today my topic is size of comparison data. When we compress the text using the Huffman code, different characters get code of different length. To calculate the total compress size, we use formula compress size is equal to sigma of f of I into L of I, where f of I is equal to frequency of character I and L of I is equal to length of that character in Huffman code. An example in the method average bit and total bit. So ASCII value 8 bits and total bit is 48. In Huffman code, using Huffman code 3.83 bits. Total bit is 23. This shows the Huffman code use a much fewer bit than ASCII, making the data almost 50% smaller. Conclusion. Huffman coding is one of the best lossless comparison technique. If compares the data without losing any information. Huffman code helps reduce memory use and file size, bandwidth, and data transfer time. Because of the efficiently is widely used in GIF comparison, JPEG image, and the MP3 folders. Many modern file formats. And thank you. Thank you.